All right. Good morning once again. So this is a second lesson on the laboratory preparation of gases. So last time we're looking at preparation of hydrogen gas. So we looked at the setup. I've labeled the setup for you. And I mentioned that hydrogen gas is prepared from the reaction between what and what? From the reaction between what and what? An acid and a metal. You guys are not reading, oh. Hydrogen gas is prepared from the reaction between an acid and a metal. So these are the two key reactants you should have in mind. Acid and a metal. So we'll be looking at that. So for this very setup, the acid over there is HCl and the metal is zinc. So that's how you get to know the gas that's being prepared. So in exam, they'll make a setup for you like this. Then you see something being mixed or poured over something. So whatever those items are, those compounds are, that should give you an idea of the gas that is being prepared. Have you heard me? They will not tell you the setup below is a setup used to prepare oxygen gas. They will not give you that claim. So it's a reactant, so that should give you the claim. So over here, the acid is, so if you look at the setup, HCl, we'll talk about acids later. After I'm done with this one. Yeah, so HCl is an acid. So plus, so everybody should write reaction. Under the setup, you write reaction equation. Because for your practical questions, the next question to ask you is write a balanced chemical equation for the reaction observed in the diagram. So here, the acid is HCl and the metal is zinc. The chemical formula for zinc is Zn. Zinc is a transition metal. So you have HCl, then you have zinc. Now, then you bring your arrow. We are looking at what is going to be produced. We said when you react an acid with a metal, hydrogen gas should be produced. Let's find out. So at the product side, now HCl is a compound. Okay, a compound consists of two elements. Okay, two elements makes a compound. So over here we have each representing hydrogen. Then we have Cl representing what? Representing chlorine. If something is new to you, you document it. Representing chlorine. Okay, now at the product side, right here, there is going to be a reaction. The positively charged element here will marry the negatively charged element here. That's what happens. Positively charged element here, which is called what? Cation, right? Cation, the positively charged. Zinc, zinc is 2 plus. The charge of zinc is what? 2 plus. I would mean. Yes. And chlorine, chlorine, the charge is -1. Don't worry, all these things I'll teach you. Or minus. We normally write minus, but it's -1. You see, chlorine is minus. So you see, zinc is positive, right? So cation, I said, is what? Positively charged atoms. That's what cations are. In exam, when you are being asked what are cations, I believe you know what to say.
Yes, sir.
Yeah. And we have anions. Anions are negatively charged negatively charged atoms. Yeah, yeah. So zinc is negatively charged. So zinc zinc is positively charged, chlorine is negatively charged. So zinc will marry chlorine. So that's what happens. So here it will be Zn, then what? Cl. So you join them together without a space, right? So zinc chloride. But you don't just write to them and go. So there is interchanging of charges, okay, or valences. So this is what happened. When you're going to marry, the man comes with something, the woman comes with something, right? I I
Yeah.
understand women, if you're going for marriage, you go with cooking tools or equipment, right? As a woman, you must have that. That's what they say, society says, right? So the woman comes with that, and the man comes with other stuff, which we all know. So the same applies here. So zinc, as you come in for the marriage, come with your charge. So zinc, we know zinc is what? +2, right? And chlorine 2 is what? Minus. Minus means -1. So as we are marrying, we'll share, right? So zinc will take the 1. So it's going to be Zn 1. Okay. Then Cl will take that of zinc. So that will be Zn1Cl2. Normally, when anything is 1, we don't write to them. So it will be ZnCl2, right? And because zinc is +2, chlorine is what? -1. So Cl will take 1, Cl will take 2, Zn will take the 1. Again, so at the product side, zinc, the cation, at the product side, the cation will marry the anion. And all the time, the cation is a metal. The cation is a metal, right? So it will marry the anion. So it's like writing the chemical symbols and you join them. But you don't just join them. Make sure you consider their charges, then you exchange it. Okay, so it's reactant that will give product. At the reactant, we had HCl and Zn. Now we've meted Zn and Cl. So what are we left with? Jeanette, what are we left with?
WH.
Yeah, H. Yeah. Mm-hmm. Okay, so what's that? Yeah, so she said H, right? I got distracted. Now, So what we're doing right here is we're writing chemical equations, okay? But there are rules governing the writing of chemical equations. There are certain elements when it means they standing alone, they must be written in a molecular form. When I say molecular form, you must include two, a subscript of two. It must appear as gas. One of the elements is hydrogen. If hydrogen should stand alone, don't write it alone. Include two. Oxygen is one. If you establishing a chemical equation and then it means oxygen standing alone, remember to bring two. Okay. Nitrogen is one. Iodine is one. Andrews, are we learning together? Are you taking science?
Yes.
Fluorine, okay. Bromine. All these elements, okay, and so much more. As and when we meet it, I'll talk about that. When you write in a chemical equation and they have to stand alone, don't write them alone, write it in a molecular form. So now this will become the reaction equation. So we have HCl plus Zn yielding zinc chloride subscript 2, right? Plus H2. I've explained everything here. Now you have to balance the equation. Balancing the equation means that whatever moles of atom on the left-hand side you see on the left-hand side must be the same moles on the right-hand side. Before we come to balancing, confirm for me if you understand everything going on. If you have a question too, you can ask. Dennis, are you following the conversation?
Yes, please.
If you have any question, the floor is open.
Please, I'm lost.
Oh, Hannah, are you there? Hannah, are you taking science? Oh, she's gone. I'm sure she doesn't.
So I do.
Okay. Yeah. Who said she's lost and how may I help you? What part?
Please, from the balance.
We've not started balancing yet, so I presume you're talking about writing of the chemical equation. So I'm saying that you see, we are seeing there's a setup used in a lab to prepare hydrogen gas. It's comprised of a list of laboratory apparatus. Now, there's a way we do it, and it's indicative in the diagram we've drawn. Now, there are certain chemicals we mix. So, one to produce this, right? So we mix hydrochloric acid. Okay, sorry, we mix an acid with a metal, and that would give you hydrogen gas. We apply a little heat. So now right here, we are showing with a chemical equation that when you when you when you react a metal with an acid, hydrogen gas is produced. Okay, so that's what we're literally doing. Now, in the setup, you see hydrochloric acid there, HCl. Then you see the metal, which is zinc, right? You write the chemical formula. So zinc is Zn. And okay, so you can watch from here again. You can watch from here again. So in the setup, in a Festo funnel, you see HCl, right? And then in the round bottom flags, you see zinc. I said the chemical formula. You have to write their chemical formulas. So this is what you see. And I'm saying at the product side, meet the cation with the anion all the time. The cation is a metal. So the metal here is zinc. So you have to meet zinc with the anion in the other in the acid, the anion in the acid. And if you know compounds very well, you notice that more a time whenever you write a compound, example, sodium chloride. Normally the anion is the one that comes at the end. Okay. The last element you see is the anion. So indirectly, zinc towards Cl, right? Yeah. That's what happens. Yeah. So mate the cation, I've explained it. Cations are positively charged atoms. The positively charged atoms, right? I told you the charge for zinc. Zinc is 2 plus, so is it not a cation? Positive. Cl, I told you the charge is minus. So it's negatively charged, it's an anion. So mate the cation with the anion. Don't just join them without exchanging their charges. So the charge for zinc is +2, the charge for chlorine is -1. So when you are marrying them, make sure zinc you interchange it. So zinc will come for 1. So it will be Zn1. Cl will come for 2, Cl2. Yeah, so Cl what 2. Forget about the sign, like plus or minus. Okay. Now, in the reactants, you see HCl and zinc, right? So at the product side, since we have zinc and Cl dealt with, what are we left with? Engineer said we are left with hydrogen, and it's true. Among the elements, what we left with is hydrogen. And I said in writing chemical equations, there are certain elements when it means they have to stand alone, write them in a gaseous state, H2. And I've listed them for you. So going forward, you meet these, they may end up standing alone. Write them in a molecular form. Now, what part don't you understand? I hope the explanation is clear.
Say,
Okay.
say,
Yes.
so the last element, if it's not a gas, you not put the 2 over there.
If it's not any of these elements, don't put the 2 there. Write it. Let it stand on its own. These are some specific elements when you have to write chemical equations and they happen to stand alone, you have to write in a gaseous state.
Say, and you also said, okay, you said all cations are metals.
Yeah, literally all cations are metals. Metals are, I don't want to complicate the whole thing, but metals readily lose electrons, right? Yeah, they are positively charged. And cations are positively charged. Do you understand? Yeah.
Yes, sir.
Metals readily lose electrons. Yeah. They readily lose electrons. That's what they are about. And in chemistry, if you lose an electron, meaning you're positively charged. If you are positively charged, connect the dot, cations. So, of course, metals are cations. Any other question?
So said the semi-metals and non-metals are anions.
Nope. Semi-metals is a different thing altogether. If you are defining semi-metals, we define them according to their characteristics or properties. Okay. So when we talk about semi-metals, they are elements whose characteristics lie between that of a metal and a non-metal. So you must know what metals are, right? You must know what metals are. You must know the properties of metals. You must know what non-metals are. If I'm saying metals readily lose electrons, non-metals gain electrons. So non-metals are anions. Do you understand? Non-metals are anions. Most non-metals, in fact, all of them are anions. All right. Now, semi-metals, their properties lie between that of a metal and a non-metal. Okay. So their properties lie between metals and non-metals. So examples of semi-metals, we are talking about silicon, germanium, okay, boron, those elements that are in group 4. Yeah, those are semi-metals. I don't want to discuss that now. We'll do that in our later discussion. Yeah. Any question? The word is semi, in between. Yeah. Any question?
No, sir.
Yeah, so now let's balance. You don't write a chemical equation without balancing. Now to balance, balancing means ensuring that the number of moles of each atom at one side becomes the same at the other side. That's what balancing means. Okay, so now when you are balancing an equation, I'm seeing a lot of things. I believe you are documenting them down.
Yes, sir.
Even with metals, non-metals, semi-metal, there are questions that will ask you define the following: metals, non-metal, semi-metal. So, and we may not have the time to talk about them. So if you hear anything, write to them. Write to them. Okay. Now I'm come to say something new. When you are balancing a chemical equation, balance hydrogen and oxygen first. It makes it easier for you. So balance hydrogen and what? Oxygen first when you are balancing a chemical equation. Yeah. So over here, which of the elements is there? The ones we prioritize, which of them do you see?
Hydrogen.
Hydrogen. Yeah, so yeah, hydrogen. So let's balance it first. So guys, watch. Over here, hydrogen is what? 1. It's 1, right? But here is 2. There's a subscript of 2 there, meaning hydrogen is what? 2, right? So to balance it, let's make hydrogen what? 2. You see that? Oxygen is not there, right? So let's carry on. So we've made hydrogen 2. Making hydrogen 2, mind you, that 2 there affects hydrogen. It becomes 2. It also affects chlorine. So chlorine has become what? How many, Janet?
2.
2. So chlorine here must be 2. But do you see who is using Techno KL4? Who is that? On Zoom. Who is using Techno KL4? You should rename your device. Anyway, so at this side, chlorine is what? 2. At the product side, chlorine is 2. So that is catered for. So we don't have to bother, right? Zinc is 1 here. It's also 1 at the product side. So the equation is balanced. We are done. So reaction equation, you write this whole thing. 2HCl plus Zn plus ZnCl plus H2. Let me know when you are done. Let me know when you are done. So what are you what are you noticing? When you react an acid with a metal, see at the product, what has been observed? H2 has been produced. Hydrogen gas. H2, hydrogen molecule, hydrogen gas. Yeah. So whenever you react an acid with a metal, hydrogen gas is produced. And guys, I want to tell you something. Most chloride compounds are salt. Most chloride compounds and sulfate compound. Chloride is Cl, right? Sulfate. SO4, right? So any compounds, most compounds that ends with Cl or SO4 are what? Salt, right? So at the product side, what is happening? Hydrogen gas is produced, right? And you see zinc chloride, that's a salt. So in a practical exam, they will again ask you, name the salt produced. And you'll be wondering, what salt? Oh, you know. So what salt is produced here? ZnCl2, that's what zinc what?
Alright,
Chloride. Yeah.
this you are done.
Okay, perfect. So I've shown you how we prepare hydrogen gas. I've shown you what and what we use to prepare it, right? Now, in exam, I said an acid and a metal. So we are going to try other acids with other metals, right? Other acids with other metals. And now we can look at uses. No, we can look at how we test for the gas. Okay, so now before I do the girl that asks about metals, I want to repeat everything all over again. So to ensure that what I've said sticks to your mind. So she asked what are metals, and I said metals are elements that readily what? Lose electrons. That readily lose electrons to become electronically stable. Metals are elements that readily lose electrons to become electronically what? Stable. And then non-metals are elements that readily accept electrons to become electronically what? Stable. Non-metals are elements that readily accept electrons to become electronically what? Stable. Okay. Then semi-metals, which is semi-metals, which is also called metalloids. I'm spelling that loids are elements whose properties lie between a metal and a non-metal. Metalloids. They are elements whose properties lie between a metal and a non-metal. And I even give you an example. So the popular ones, we have silicon. Then we have germanium. Germanium. I don't know if Constantine is a semi-metal. Okay. Okay. Constantine. I don't know if I'm getting there. I hope what I'm seeing you writing.
Yeah,
Um,
actually, I use
It's not. It's not. Yeah, it's a halogen right now. Yeah. Yeah, so silicon, germanium, and I think boron. You can look it up. Yeah. I'm sure boron, yeah. I'm putting an asterisk there. Look at that boron. Mm. Metals are elements that readily lose electrons to become electronically stable. Non-metals, they are elements that readily accept electrons to become electronically stable. Semi-metals are elements whose properties lie between metals and non-metals. Properties lie between that of a metal and a non-metal. Or metal, I don't know if we ever get a chance. If I'm talking about that, I'll one day produce a periodic table to you. If I draw it, you easily see the metals. You easily see the metals, but they are normally in group 1 to 3. Non-metals are from group 5 to 7 or 8, yeah. Yeah, 5 to 8, yeah. And semi-metals are in between, group 4. Okay, can we go on?
Yes.
Okay, so um So this is the reaction equation for the setup, because in the setup you saw zinc and HCl, right? In other questions at the top, when I talk about thistlefanol, I believe you know what I'm talking about.
Yes.
I'm coming. Someone texted me. Okay. Yeah, so in the first, those that are just joining, the thistlefanol is there, the funnel at the top there, right? So you go to an exam hall and you get a setup, and in a setup, the thistlefanol you have this each. No, they will even write this for you. Nitric. I'm coming, guys. They'll write nitric acid. Then in the round bottom flask, maybe they'll write sodium. No, or I should get a complex metal like magnesium. Are we together?
Yes, sir.
They'll just write these. Now you start. We'll look at the periodic table soon in our next meeting, okay? But at least that acid there should suggest to you that it's an acid, right? Magnesium, you later know, is in group 2. Group 1 to 3, they are all metal. So magnesium is a metal. Don't worry, today I'm telling you, but going forward, in fact, I'll give you an assignment. Going forward, you get to know because I'll teach you tomorrow. So we have nitric acid. Then we have magnesium. Now, nitric acid, the chemical formula is NO3. Okay. Sorry, HNO3. It's an acid, so there should be HNO3. Okay. The magnesium, of course, what's the chemical symbol? Magnesium. What's the chemical symbol? I can't hear you. What's the chemical symbol for magnesium?
Mg.
Mg. Good. So now, you see, it's an acid, it's a metal. At the end of the day, what should be produced? Hydrogen gas, right? Yeah, hydrogen gas. So let's see. So you have HNO3, right? Plus Mg producing. Yeah. Now I said at the product side, the cation must react with the anion, right? And I said all the time, the cation is a metal, right? So it should be Mg, right? And the anion is mostly what is towards the end. Okay. People might think it's O3, but I'm here to tell you something. Even though you see 3 different elements, H, N, and O3, actually, whenever you see N, O3, it's a family. We see them as one. Husband and wife, they go together. You can't separate them. There's a name we give to them. We call them radicals, the whole class. Again, yeah, not only them. Another one is H3O. Hydrozonium. It's called hydrozonium. They go together. So when I see them, you can't say, oh, you can't write just, oh, no. You have to write us together. You can't separate me from my wife. We must move along together. Do you understand that? So Yeah. So even though you were thinking, could it be O3? No, it's NO3. Okay. So going forward, I'll write other compounds for you like this. H2SO4, right? So the anion here, I don't think it's O4, but what would you say, guys?
SO4.
Good, yeah, because it's a radical. It's a radical. It's a family. I will explain what radicals are. It's a family, right? So it should be Mg what? The cation will marry the anion, and the anion here is agreed that is what? NO3.
NO3.
Yeah. So they are going to marry together. Okay. And I said when you are marrying the woman, you have to bring something to that. But does it really happen? The woman goes with cooking utensils. Does it really happen in reality? Our forefathers used to say so. Said you must get those items down. In modern era, does it happen?
Yes.
So the wife goes to the husband's house with cooking equipment, silvers and stuff. It happens, eh?
Yes, I
And the man goes with what? Money. Yeah. Money. Okay. Yeah, so you can't come and meet with me without I'll explain radical soon, okay? Without we exchanging what we have. So that's where the charge come in. So today I'm teaching you, but in our next lecture or when you go home, it should be in your interest to identify examples of metals, examples of non-metals. Okay. Yeah. No, here is metals and acids. So examples of metals, examples of acids. It should be your business to research on that. I would mean. And how we find charges. So actually the charge for magnesium is +2. That's why you normally see us writing Mg2 plus. The charge for NO3 is -1. So that family, they work together. Their charge is minus. H3O, they work together. Their charge is plus. When we start talking about acid, base, and salt, you see this family a lot. Hydrozonium. Okay. SO4, they work together. Their charge is 2-. They are all radicals. So NO3, I said that family, their charge is -1, right? So document these radicals down and their charge. So when you will see them SO4, you'll be seeing it soon. Don't be surprised. So knowing their charge, Mg will come and take what? 1, isn't it?
Yeah.
By Mg1, we don't write it. Then NO3 will take what?
Minus.
Will take what?
Minus.
What is
Two.
she saying? Mg will take what?
-1.
1. -1.
1. Just forget about the sign. Mg will take 1. NO3 will take what?
2.
2. So listen, NO3 is a family. So bring a bracket, then you bring the 2 here. If you write NO3, then you bring 2, you are being biased. It's like you're giving the 2 to just the O. So bring a bracket. Do you understand?
Yes.
This, by so doing, you've married them well. MgNO3 2. You've married them well. I'm done. Then you see, look at the elements here. You have dealt with MgNO3. What is left, guys?
H.
And
Hydrogen.
I told you something about each element like hydrogen, oxygen, fluorine, and stuff like that. They must be written in molecular form. So what should I write? 2.
H2.
H2. Then now we balance. For balancing, I said balance what and what first?
balance.
Oxygen and hydrogen.
Oxygen and hydrogen first. This brings us to the end of this lecture. Your assignment is the two assignments I gave you, which is examples of gases that are prepared using two additional gases prepared using upward delivery, one additional gas prepared using downward delivery. Today, your assignment is you are to go home and read about how to calculate for the charges, right? You are also to go home to look at examples of metals and acids, right? And you are to balance this. I don't want to do that and it's going to be a lot. So I'm going to save this piece. When next I meet you, I'll open this up. Go and balance this. Balance hydrogen and oxygen first. Your goal is make sure the moles here on the left hand side is the same as the moles on the right hand side. Any question? And listen, in case it's not up to and you want to add up, do not bring any number here, like any number here. No. Numbers can appear at the right side when you are marrying them. So if you have any number to add, you don't add it at the right subscript, right? No, don't bring it there. If you want to do any addition, you can only put it in front of the numbers. You get it? In front of the letters. That's the only place you can put them. Okay. That's the only place. You can't put it at the right. Okay. This brings us to the end of the session. I'm going to end the recording now. Of course, you should like the video if you appreciated the every discussion we had today. Thank you.